Hello, this is the second video to help you understand kinetic and potential energy conversions. What you have here is a picture of a battery, and you know batteries have a negative and positive terminus. The chemical reaction in the battery can't occur until you complete the circuit. So when you connect it to the motor, you can see that wire is going to finish the circuit and allow the chemical reaction to happen. And because of the second law of thermodynamics, the electrons in that chemical reaction are going to go from a higher energy state. They're going to obey that second law of thermodynamics, and they're going to go to the lowest energy state. Where does that energy go? Well, as you can see, I've coiled the wire around here around an axle, and that axle is going to spin. So the chemical potential of the battery and those electrons, as it goes through the coil, the energy is used and converted into mechanical kinetic energy. Something I want to quickly point out here is if we have a decrease, and we'll just say 100 joules of energy, which you should now know joules is the unit of energy. If 100 joules of energy comes out of the battery, you're never going to get 100% conversion. This is because energy is lost due to friction, and that friction causes heat. So even though energy can't be created or destroyed, the energy going into the kinetic of the mechanical turning of that axle could be as low as 50 joules. Let's be nice and let's say it's 80 joules. That means we actually lose 20 joules of energy to friction. And this is why things lose energy and get hot. If that axle wasn't there and we didn't convert it into kinetic mechanical energy, the electrons would flow really fast, and that battery is actually going to get really, really hot. The energy has to go somewhere, so the battery gets hot, and you're going to lose all 100 joules just as heat. Okay, so this is the second one. We're going to zoom in on what's happening in the battery right after this.